We live in an era of rapid technological change. Exciting innovations are emerging across industries, promising to transform our world in profound ways. From transportation to medicine, energy to computing, new technologies aim to make our lives safer, easier, and more efficient. Here we explore 20 groundbreaking technologies that have the potential to reshape our future. 1. Sora. You may have heard of the parallel world, where everything we do, feel, think, and imagine would also happen in another world. Sora is a technology that, according to experts, may stimulate our world into an imaginary realm that will look the same as our real world. Sora is a text-to-video generating tool from OpenAI. If you think it is only a text-to-video generation tool, you are wrong. This tool does not just create video, it actually thinks, calculates the dimensions, creates new scenes, mimic the entire physical world with the use of AI technology. With a single command, you will be able to convert your imagination into a 3D stimulated virtual reality world. Currently, Sora has been trained in Unreal Engine 5 scenarios. Soon, everybody will be able to make their own world, aka comfort zone. 2. Self-driving cars. Self-driving car technology has progressed in leaps and bounds in recent years. Companies like Tesla, Waymo, Cruise, Pony.ai, and Zoox are leading the way in developing autonomous vehicles equipped with advanced sensors and artificial intelligence. These cars can navigate roads, obey traffic rules, and avoid obstacles without human intervention. Though some challenges remain, self-driving cars are poised to disrupt transportation and mobility. They promise major safety benefits by eliminating human error, which causes most accidents today. Autonomous vehicles could also enable new mobility options for the elderly and people with disabilities. With the potential for increased road capacity and reduced traffic congestion, our daily commutes may never be the same. 3. Hydrogen fuel cell. Hydrogen fuel cells offer an eco-friendly alternative to fossil fuels for powering vehicles and buildings. Fuel cell systems produce energy by combining hydrogen and oxygen. The only byproduct is water, resulting in zero emissions. As hydrogen infrastructure ramps up, fuel cell vehicles are expanding beyond prototypes to commercialization by companies like Toyota. Small-scale fuel cells can also provide clean backup power or off-grid power solutions. Data centers increasingly use hydrogen fuel cells to supplement grid power for improved uptime and green credentials. With falling costs and investment in hydrogen fueling stations, fuel cell technology may finally be poised to take off. 4. Hyperloop. First envisioned by entrepreneur Elon Musk, the Hyperloop involves levitating passenger pods through near-vacuum tubes at airplane-like speeds. This new mode of transportation promises to connect cities less than 1,500 kilometers apart in under an hour. Hyperloop systems use magnetic levitation and linear electric motors to propel pods through tubes at speeds of over 1,000 km/h. This allows for high-speed transportation that is faster than air travel and more sustainable than jet fuel. With prototypes already demonstrating feasibility, commercial Hyperloop systems could emerge within the next decade. 5. Augmented reality contact lenses. Mojo Vision is developing smart contact lenses with tiny built-in displays for augmenting our visual field, integrating micro-LEDs, motion sensors, and wireless chips. These lenses can overlay digital information directly into the wearer's line of sight. Augmented reality contact lenses offer seamless integration of graphical data into daily routines. Directions, notifications, and even vision enhancements could be beamed straight to our eyes. Besides enabling futuristic cyborg-like abilities, smart lenses can assist people with visual impairments. This emerging technology promises to integrate virtual overlays into our lives in a remarkably natural fashion. 6. Quantum computer. Conventional computers process information in binary bits with values of 0 or 1. Quantum computers leverage quantum physics phenomena to perform calculations exponentially faster. They use quantum bits or qubits, which can exist as 0 and 1, simultaneously, enabling massive parallel processing. With capabilities unmatched by classical computers, quantum systems promise to transform everything from drug discovery to climate forecasting. Major investments from governments and corporations like IBM and Google are helping develop practical quantum computers. As quantum computing goes mainstream in the next decade, traditional encryption and security systems may even need major upgrades to remain effective. 7. Robotic Suitcases. A pioneering consumer application for autonomous robotics is the Robotic Suitcase. Startups like TravelMate Robotics have developed robotic luggage that uses cameras and obstacle detection to autonomously follow its owner in airports, hotels, and beyond. The smart suitcases integrate motors and batteries to roll behind travelers at a constant distance. This hands-free luggage simplifies airport navigation and reduces the hassle of lugging around heavy bags during travel. While still in the early stages, autonomous suitcases point to the potential for promising consumer robot applications. 8. Biometrics. Biometric authentication uses unique biological attributes like fingerprints, face, iris, or voice to verify identity. It provides convenience and highly secure access. Fingerprint scanning smartphones like the iPhone have already normalized biometrics. Now, biometrics is finding wider applications. Airports and national ID systems are increasingly turning to biometric identification. Banks are introducing cardless ATMs authorized by fingerprints and facial recognition. With biometric data hard to forge or steal, technology promises to combat identity fraud and cybercrime in the digital era. 9. Energy harvesting floors. Innovative flooring systems can now harvest the kinetic energy of footsteps to power buildings. Piezoelectric crystals or electromagnetic generators are used to capture pressure and vibrations as people walk. Startups like Pavigan are installing energy harvesting floors in offices, stadiums, train stations, and more. Footstep energy alone can't meet total electricity needs but can offset consumption. The advanced floors also encourage more walking. Installing these floors provides sustainable, renewable energy from footsteps we already take every day. This technology transforms human movement into a clean, cost-effective power source. 10. SelfHealing Concrete. An exciting advance in building materials is SelfHealing Concrete. It uses special limestone-producing bacteria and calcium lactate encapsulation to seal cracks that develop over time. This concrete eliminates the need for repairs and reduces maintenance costs. When cracking occurs, the bacteria germinate in the crack to precipitate limestone that fills up gaps. Meanwhile, the encapsulated material reacts with water to supply limestone precursor. With piloting projects already demonstrating success, SelfHealing Concrete offers great promise for new construction as well as restoration and increased longevity of existing structures. 11. Solid-state batteries. Today's lithium-ion batteries power everything from smartphones to EVs, but they use liquid electrolytes that can overheat and have limited energy densities. An alternative gaining momentum is solid-state batteries. These use solid electrolytes and lithium metal electrodes for stability, longer life, faster charging, and higher energy density. Solid-state batteries are poised for commercialization in coming years, with several high-profile companies like Toyota, QuantumScape, and Solid Power working on the technology. By replacing liquid cells with solids, these next-gen batteries can expand the capabilities and performance of cell phones, laptops, drones, EVs, and the electrical grid. 12. 3D printing additive manufacturing. 3D printing builds physical objects layer by layer from digital designs. As 3D printers become faster, more accurate, and work with more materials, applications are rapidly expanding. It enables on-demand manufacturing that is localized, flexible, and customizable. 3D printing is moving beyond prototypes to finished products, from airplane and car parts to clothing and human organs. This disruptive technology reduces waste, transportation, and inventory needs. It unlocks design opportunities not possible with traditional methods. 3D printing democratizes manufacturing, allowing businesses and consumers to innovate and produce new products at unprecedented economies of scope and scale. 13. Artificial intelligence, AI. AI, enabling machines to mimic human thinking capabilities through learning algorithms, neural networks, and vast data processing, is already impacting our lives in profound ways. AI powers services like search engines, digital assistants, recommendations, facial recognition, translation apps, and more. But the next decade will see more transformative AI applications across industries. AI enables self-driving vehicles, advanced medical diagnostics, hyper-accurate weather forecasting, individualized education, and much more. As a foundational technology, AI will shape the future by enhancing knowledge, insight, and decision-making. 14. Autonomous mobile robots. Mobile robots with autonomous navigation are disrupting a range of sectors from warehouses to healthcare. Equipped with sensors like LiDAR, 3D cameras, and AI-powered object recognition, these agile robots can move independently to undertake various tasks. In controlled settings like warehouses, autonomous mobile robots can efficiently move inventory without human intervention. In hospitals, they can transport medical supplies or hazardous waste, freeing up staff. Companies like Ethon, Fetch Robotics, Omron, and more are spearheading the autonomous mobile robot revolution across diverse industries. 15. Virtual and augmented reality. Both virtual reality, VR, and augmented reality, AR technologies are finding diverse applications that go way beyond entertainment and gaming. VR headsets allow wearers to interact with immersive simulated environments. AR overlays digital elements onto real-world views through special headsets or smartphone cameras. Extended reality technologies are now being used for military training, telemedicine, industrial design, and more. As these systems become more advanced and realistic, we may eventually communicate through virtual avatars or have virtual companions. The potential of VR/AR technologies to revolutionize learning, design, medicine, and work collaboration remains enormous. 16. Smart fabrics and wearables. From health tracking to haptics and gesture control, smart fabrics and wearables are enhancing our daily lives. Companies like Hexoskin and OM Signal create smart clothing with biosensing textiles to monitor health data. Athos workout clothes measure muscle exertion. Levi and Googly's Project Jacquard offer touch-sensitive smart jackets for controlling phones via hand gestures. Stretchable circuits and e-textiles also enable lightweight music players or navigation devices embedded into clothing. Meanwhile, hearable devices like Doppler Hear One translate languages and transcribe conversations on the fly. Our apparel may soon monitor health, improve safety, and increase connectivity through advanced fabrics. 17. Blockchain. Blockchain provides secure digital ledgers for recording transactions through decentralized networks of computers, providing transparency, trust, and authentication, while complex blockchain forms the backbone for cryptocurrency transactions without traditional intermediaries. Blockchain technology has applications well beyond digital currencies and asset management, though. It can verify credentials, contracts, policies, and identity. Supply chain tracking and electronic health records also benefit from tamper-proof distributed ledgers. As security and transparency become increasingly critical, blockchain promises foundational transformation in record-keeping and exchange. Gene therapy. Gene therapy addresses genetic abnormalities at their root biological cause rather than just ameliorating symptoms. It modifies gene expression by introducing, suppressing, or changing specific genes responsible for a disease.